Page 583, there's this example about evaluating factorial expressions, and we're going to look at some different examples there. First question is, how do you pronounce that? So you guys know what that is, right? 3 times 2 times 1. Or 1 times 2 times 3. You can do it either way, right? Yeah. Now, some of you are going to like it one way better than the other. And a little later, we'll see that kind of play out even more apparently, that you think about it as being from the number down to 1, or you think about it as being from 1 up to the number. But in this case, it's 6 both ways, right? Yes, good. Now, hopefully you caught in your notes what that is. Okay? This is defined, 0 factorial is defined to be 1. Doesn't make any sense, but it's defined to be 1 in order to make the universe not explode. So we thank our mathematician friends for taking that into consideration. It just is, right? It makes things work out well for us. Okay, then let's think about this one for a second. What is 3 factorial divided by 2 factorial? Okay, how do you do that?
You expand it and then cancel out.
So approach number 1, like TJ says, is 3 times 2 times 1 divided by 2 times 1, and then we cancel that, and we cancel that, we cancel that, and we cancel that, and we're left with 3, right? Everybody good with that? Now, you can also do 3 factorial over 2 factorial is what? 6 over 2 is equal to 3. And some of you probably did that when you got some of these factorial expressions. However, that doesn't work out too well if you get 101 factorial over 100 factorial. Now, if you ask your TI-80 whatever to do 101 factorial, what does it do? Yeah, it gives you an error for anything bigger than 69. That's the limit of what you can do for factorials on your calculator. So for something like this, you don't have any choice except to expand it and divide the common terms. So to do 101 divided by 100, you're going to write out 1 times 2 times 3 times 4, and you're going to write all 101 terms, right? Okay, so you don't want to spend your time writing to 101 when you know that the answer for 101 factorial over 100 factorial is what? Now, how do you know that? We could rewrite this as 100 factorial times 101, right? 101 factorial is the same as 100 factorial times 101. Nod your head if you agree with me. Yes, Mr. Wyatt. Okay. And then we divide that by 100 factorial, and now we can do our little dividey thingy that says, oh hey, 101 factorial divided by 101 factorial is just 1, and I'm left with 101. Now, everybody's okay with that. If you're not, now is the time to stop and let's sort it out. Because we're about to move to the next step where you're going to look at me like I quit speaking English and started speaking a different language. Okay, let's go for it then. If we have n factorial over n minus 1 factorial, what is that? What did I tell you about speaking a foreign language? Say what? It's n. Why? It is exactly the same thing as 101 factorial over 100 factorial. If we write this as n minus 1 factorial divided by n minus 1 factorial and an n up there, what's left is we cancel the n minus 1 factorials and we're left with n. Okay? Now, we can write that same idea as n factorial over n minus 1 factorial, and here's where the question starts coming in on example 6 in the book. We can write this as 1 times 2 times 3, and then we put in our dot dot dots representing all of the numbers between 3 and n minus 1 and n. Okay? Now, do you agree with me that what's on top there is exactly the same as n factorial? 1 times 2 times 3, continued until we get to n minus 1, and then n. Okay? Then we can write the bottom is 1 times 2 times 3 up to n minus 1. So now we have n factorial on the top, n minus 1 factorial on the bottom. If we cancel all of the things that are in both the top and the bottom, all of those go away, and all of those go away, and we're left with n. Everybody okay with that? Some of you will like it a lot better if you write it as n minus 1, 3, 2, 1, n minus 1, dot, 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 3, 2, 1. That's okay. It's one of those, do you see it as a additive thing or a subtractive thing? It's sort of like when you were learning to model an inventor and you were given the opportunity to take a big box and take away the pieces that you didn't want, or take a small box and add things to it. Some of you did it both ways. This is sort of the same idea. Do you start with the big number and count down, or do you start with 1 and count up? You still get to the same thing. So let's look at another example here. How about n minus 1 factorial over n plus 2 factorial? What is that? Not quite. Let's expand the top, and we get 1, 2, 3, up to n minus 1, right? Let's expand the bottom. 1, 2, 3, n minus 1, n, I ran out of room, so n plus 1, and n plus 2. Where do we quit being able to cancel things? N minus 1. So we can cancel all of these and all of these, and we're left with 1 over n, n plus 1, n plus 2. Okay? Now then, look at that one for a minute. Are you okay with how that worked out? Okay? In my experience with this section, this is the only thing that creates some trip hazards, is these factorial expressions where you're all perfectly happy finding factorials of numbers, but finding factorials of expressions makes you back up and have to try it a time or two. So if this one is okay and you can do that, then you should be good. Now this is one of the things that we cover because this is a pre-calculus class. Doing factorial expressions is something that comes in pretty handy in calculus. Okay, questions about that? Yes?
How'd you get the n plus 1?
Here, this one? Okay. Because the bottom expression, the denominator, is n plus 2, right? So that means this is exactly the same as, let me rewrite this, n minus 1 factorial over n plus 2 factorial. So let's just leave this as n minus 1 factorial, and then let's write that as n minus 1 factorial, but I have more terms on the bottom because I have to also have n plus 1, and n plus 2. Let's think about it in terms of numbers. Let's let n equal 5. Okay? So n minus 1, that's going to be 4 factorial, right? N plus 2 is 7 factorial. And we're going to let n equal 5. So this thing on top is just 4 factorial. The thing on bottom is 4 factorial times 5 factorial, sorry, not 5 factorial, that's dumb, times 5 times 6 times 7. Okay? This is n minus 1, this is n plus 1, and that's n plus 2. Okay? So since this expression up here was n plus 2, we have n plus 1, and n plus 2 as additional terms in the denominator that we don't have in the numerator.